lesson 2 of sequences and series for grade 12, and our first question here is 112 a term in this arithmetic sequence? Well, remember the formula for an arithmetic sequence. Tn is a plus n minus 1 lots of d. What we're going to do is we're going to say, let's make it a term, 112, let's make it a term and see which one it is. We know that a is 4, and we know that d is, remember d is any term minus the term before, is actually 2.5. Now we've got to solve this little equation. Let's subtract 4 from both sides. We get 108 is 2.5 lots of n minus 1. We're now going to divide both sides by 2.5, all right, and then we're going to add 1. So n will end up being 108 divided by 2.5 plus 1. And we end up getting n equals 44,2. Now, if n is 44,2, then the answer to this question is no. Right, 112 is not a term in this sequence. We can't have the 44,2 term, all right? N has to be a natural number, and in this case, n is not a natural number. So therefore, no. Right, let's move to question 8. The first 3 terms of an arithmetic progression are given as such. Now remember that the second one minus the first one must be the same as the third one minus the second one. So 2x minus 6 minus x minus 2 must be the same as 4x minus 8 minus 2x minus 6. That's true for every arithmetic sequence. The third term minus the second term, or in fact any term minus the term before it, must be equal to any other term minus the term before that. On the left-hand side here, we get 2x minus 6 minus x plus 2. And on the right-hand side, we get 4x minus 8 minus 2x plus 6. And that comes to x minus 4 on the left and 2x minus 2 on the right. We're now going to subtract x from both sides, and we get x minus 2 on the right and minus 4 on the left. And then lastly, we're going to add 2 to both sides, and we get a final answer of x equals minus 2. Right? I would be tempted just to put that value for x into these terms, and indeed when we do, we see we get minus 4 from the first term, we get minus 10 from the next term, and minus 16 from the third term. And those indeed are in arithmetic progression. We are adding negative 6 each time, so this is definitely correct. The next concept we're going to talk about is something called arithmetic means. All right, and arithmetic means are numbers that fit in between some numbers in order that the entire thing makes an arithmetic sequence. So here we've got the number 8, negative 8, and we've got the number 6. And we want to put 3 arithmetic means in between those two numbers in order that all 5 numbers will form an arithmetic sequence. Right. Now, if we've got this, we know that a is our first term. And in fact, 1, 2, 3, 4, 5, our fifth term is 6. Remember our formula? Tn equals a plus n minus 1 lots of d. What I would like to find out is what is the common difference? Because if I know the common difference, then I can fill in these missing terms. Right, so let's fill in what we do know. We know that the fifth term is 6. So in other words, 6 happens, we know a is minus 8. 6 happens when n is 5. Now this equation only has one variable left in it, and we should be good enough to solve for that. Right, we're going to add 8 to both sides, and we get 14 is 4d. We're now going to divide both sides by 4, and we get 3.5. Right, as a final thing now, let's just put in those missing terms. Right, so in fact they are going to be, we're going to start off with negative 8. If we add 3.5 to negative 8, we get negative 4.5. If we add 3.5 to negative 4, we get negative 1. If we add 3.5 to negative 1, we get 2.5. And lo and behold, if we add 3.5 to 2.5, we get 6. So these three numbers here are the arithmetic means that we've inserted. Okay, let's try a couple. All right, probably a good idea to just sort of pause it and see if you can do these yourself. Right, but let's have a look. This time we want to put in two arithmetic means between 25 and 46. Now if we do that, this term over here will in fact be the fourth term. So we will know A and we will know T4. Right, let's just write those down. A will be 25 and T4 will be 46. Remember our formula? Keep writing it down because we want it to come very quickly to you. A plus n minus 1 lots of D. There it is. Now, because the fourth term is 46, 46 will be A, which we know is 25, plus 3 lots of D. Right, let's solve this little equation. Remember the idea of a balance. Whatever we do to the one side, we must do to the other. We're going to subtract 25 from both sides, leaving 21 on this side and 3D on this side. Next up, we're going to divide both sides by 3, and we get D equals 7. All right, so in fact, if we start off with 25 and we add 7, all right, we get to 32. If we add 7 again, we get to 39. And if we add 7 again, we get to 46, which was our final term. So we definitely have that one correct. Let's try another one. This time we're going to insert 5 arithmetic means between 14 and negative 4. There's 14. 1, 2, 3, 4, 5. Those are going to be our arithmetic means there. And then we've got negative 4. Clearly D is going to come out negative because these terms are decreasing. Right, what we know is we know that A is 14 and D is A is 14 and T 7. 1, 2, 3, 4, 5, 6, 7 is minus 4. Right, here's our formula. Tn equals A plus n minus 1 lots of D. And so negative 4 equals 14 plus 6 lots of D. We're going to subtract 14 from both sides, right? And when we do that, we get negative 18 is 6D. And we're now going to divide both sides by 6, and we get D is negative 3. So our arithmetic means are 14. If we add negative 3, we get 11. If we add negative 3, we get 8. If we add negative 3, we get 5. If we add negative 3, we get 2. If we add negative 3, we get negative 1. And lastly, if we add negative 3 to negative 1, we get negative 4. And those there are our arithmetic means. Okay, in all the work we've done so far, we have solved equations where we've only had one variable. As we know from mathematics, we are able to solve for two variables if we have two equations. Right, so let's look at this one. This time we're told that an arithmetic progression has a 12th term of 80 and a 17th term of 115. So what we're going to do is we're going to try and build two equations in order to work out the first three terms. What we really would like to know for the first three terms, we'd love to know what is A and what is D. If I know A and D, then I'm home and dry and I can write down any number of terms. Right, remember our formula? Tn is A plus n minus 1 lots of D. Right, we know that 80 is A plus 11D. And we also know that 115 is A plus 16D. Okay, now we've got an equation here that's got two variables in, A and D. We've got another one here that's got two variables in, and we're going to solve them simultaneously. Now, there are different ways of solving simultaneous equations. One of them is to isolate one of the variables. In other words, make A the subject of the formula and then substitute it in. But a clever way that will work well for us here is the process of what we call elimination, right? If I take these two equations and I subtract them from one another, it doesn't matter which order I subtract them. I'm actually going to go the bottom one minus the top one. In other words, I'm going to go number 2 minus number 1. When I do that, I get 35 over here, and a minus a, no a's, 16 minus 11, 16d minus 11d, 5d. Lo and behold, all right, and we're going to say, aha, all right, lo and behold, I only have one variable left. Now I can divide both sides by 5, and I get that d equals 7. Now what I do is I take this value of 7 and I substitute it into one of these equations. All right, I'm going to put it into equation number 1. AT equals A plus 11 lots of 7. All right, there's the 7 that I've just worked out. That's my D value. Now, once again, I've got an equation with only one variable in, and I get that AT is A plus 77. Let's subtract 77 from both sides, and I get A equals 3. All right. We may think, oh, we finished. All right. We're actually not finished. Let's go back and read the question. The question said, what are the first three terms? Well, the first term is going to be A. It's going to be 3. Then I'm going to add my D of 7. And I'm going to add my D again. And those, in fact, are the first three terms. All right. Let's try another one. Okay, this time we again are asked to find the first three terms. We know the 4th term and the 15th term. I keep writing the equation down. We need to get this thing to stick in our heads so that we can do it fast and quickly, fast and accurately. So, all right. So equation number 1 is going to come from the fact that the 4th term is 23. So 23 is A plus 3D. That's great, but it's got two variables in. I need another equation. Term 15 is 100, which means 100 is A plus 14D. Right. This time, I'm going to subtract them, and I'm going to go number 1 minus number 2. Just to show you that it actually won't matter. We can do it either way. If I go 23 minus 100, I actually get negative 77. The A's cross out, all right, and I get negative 11D. Right. So once again here, D is 7. If I divide both sides by negative 11, I get D equals 7. Then what I need to do is I need to substitute that value of D into one of the equations. I can use either equation. I'm going to use equation number 1. So 23 is A plus 3 lots of D. And remember, D I've just worked out to be 7. So in fact, 23, sorry, this should be an equal sign. 23 equals A plus 21. Subtract 21 from both sides and I get A equals 2. I'm not finished. I need to write down the first three terms, and they will be 2, add 7 is 9, add 7 is 16. Okay, let's try another one. This time we've got T7 is 5 and T17 is minus 20. Well, here's the formula. So 5 will equal A plus 6D, and minus 20 will equal A plus 16D. Let's subtract them. This is number 1. This is number 2. 5 minus minus 20. I'm going number 1 minus number 2. 5 minus minus 20 is actually 5 plus 20. It's 25. 6D minus 16D, all right, is minus 10D. What I'm going to get here is I'm going to get that D is 25 over negative 10. It's negative 2.5. Right. I'm going to substitute that value in. So what it's going to look like, it's going to look like 5 equals A plus 6 lots of negative 12. Sorry, 6 lots of negative 2.5. Right. And what I get here is, sorry, I get 5 equals A minus 15. And so I actually get A equals 20. This question just asks for the first two terms, and those will be 20. And if I take off 2.5, in other words, if I add minus 2.5, I get 17.5. Right, this next one's slightly more complicated because it doesn't ask us for the first 3 terms. It gives us information about 2 terms and then asks us to find, in fact, the 8th term. Right, we're going to proceed exactly as we did previously. Here's our formula. And we're going to work out A and D, because once we know A and D, then we can easily work out T8 using the self-same formula. Right, from the fact that T5 is 19, 19 is A plus 4 lots of D. And from the fact that 79 is the 20th term, 79 is A plus 19D. This is equation number 2. This is equation number 1. And now I'm going to subtract the 2 equations. I'm going to go 1 minus 2. Right, could just as easily go 2 minus 1. All right, 19 minus 79, negative 60. A minus A, no A's. Yippee, I've only got 1 variable left. 4D minus 19D minus 15D. I'm now going to divide both sides by negative 15, and I get that D is positive 4. I'm now going to substitute that value in, all right, into equation number 1. I've got 19 is A plus 4 lots of D, all right, and I've just worked out, in fact, that D is 4. So I get 19 is A plus 16. Let's subtract 16 from both sides, and we get A equals 3. Let's remind ourselves what the question asked us to do. It asked us to find the 8th term. Right, now, the formula for the 8th term is just going to be T8 is going to be my A value plus 7 lots of my D value. And I get a final answer here that my 8th term is, my 8th term is 31. Right, let's look now at a kind of real-life example of a sequence. Right, Tabo runs 500 meters on his first day of training. Thereafter, he runs 300 meters further each day. How far will he run on the 8th day? Well, let's write down a few terms. On day 1, he runs 500. On day 2, he runs 800. On day 3, he runs 1100. Right, what have we got here? This is an arithmetic sequence, and we know that A is 500 and D is 300. So A is 500, D is 300. And we, in fact, are being asked for the 8th day, the 8th term. Right, so we've got our formula, Tn equals A plus n minus 1 lots of D. Right, so T8 is going to be 500 plus 7 lots of 300. Right, and it comes to 2600 meters. Right, remember the prefix kilo means 1,000. So if we divide this by 1,000, it would be 2,6 kilometers. Okay. On which day will he first run more than 10 kilometers? So now what we're wanting to find out is we're wanting to find out which term is equal to 10,000. Right, 10 kilometers, 10,000 meters. Right, here's our equation. Tn equals A plus n minus 1 lots of D. Right, and what we get is 10,000 is 500 plus n minus 1 lots of 300. Let's solve this. We're going to subtract 500 from both sides, leaving 9,500, and that equals 300 lots of n minus 300. Now we're going to add 300 to both sides. We get 9,800 is 300n. We're going to divide both sides by 300. We get about 32,7. Right. That means that 10,000 is not a term in the sequence. But what we know is that on day 32, Thabo would have run slightly less than 10,000, and on day 33, more than 10,000. So day 33 is going to be the answer to this question on the 33rd day. 33rd day, you will run more than 10,000 meters for the first time, more than 10 kilometers for the first time. Okay, and that brings us to the end of lesson 2.